Chapter 11 deals with sequences and series. Specifically, we're going to talk about two types of sequences. We're going to talk about arithmetic and geometric. However, there are more than just that. So this first section, we're just talking about mathematical patterns and how sequences are formed. So what is a sequence? Well, a sequence is an ordered set of numbers. A sequence can be found by using any type of pattern. So it could be that you're adding or you're multiplying or whatever it may be, just some pattern. There are two types of formulas that you can write when you're dealing with sequences. There's what's called a recursive formula and then an explicit formula. So let's start with a recursive formula. A recursive formula expresses the general term of a sequence in terms of its previous terms. Here's what this means. What that would mean is that in order to find the second term, you have to know the first term. So then to find the 10th term, you would need to know all 9 terms before it. So in a recursive formula, you can't find a term in the sequence until you know everything before it. Now, just some notation for you to know, when you see a sub 1, that indicates the first term in the sequence. N is the number of the term, and then a sub n is the nth term of a sequence. So let's say that you have this sequence here, 3, 7, 11, 15, and so forth. Notice, first of all, how it's formed. We're adding 4 every term to get the next one. So 3 plus 4 is 7, 7 plus 4 is 11, and so forth. So if I said, what is a sub 1? That would be 3, because 3 is the first term in the sequence. A sub 5 is 19, because 19 is the 5th term in the sequence. So that's just some notation to make sure you know. Now, in terms of a recursive formula, here's how it's going to be given to you. You're going to be given an a sub n formula, but you'll also be given a sub 1, because remember, in order to find a term, you have to know the term before it. So if you had to find the first term, there's nothing before the first term, so you have to know the first term to start. So anytime you're given an equation or a setup that looks similar to this is going to be recursive. So if I were to say to you, find the first 5 terms, well, you already know the first term is 7, which means now you need to start with the second term. So we want to do a sub 2. What that means is that wherever you see an n in this equation, you're going to substitute a 2. So when we put a 2 into our equation, we would have a sub 2 equals a sub 2 minus 1 plus 5. Now this little sub right here, 2 minus 1 is 1. So that gives you a sub 1. But you know what a sub 1 is. A sub 1 is 7. So we're going to do 7 plus 5, which is 12. That's your second term. To find your third term, you're going to plug in a 3 wherever you see an n. So that would give us a sub 3 minus 1 plus 5. 3 minus 1 is 2, so that's a sub 2. Well, a sub 2 is 12, so 12 plus 5 is 17. Now at this point, you may begin to see a pattern, and so maybe you don't have to do the formula the rest of the way. Like you might see that you're just adding 5 every time to your numbers, and that's okay if you recognize that. Otherwise, to find the 4th term, you're going to plug in 4, and then to find the 5th term, you're going to plug in 5. So the first 5 terms are 7, 12, 17, 22, and 27. Let's look at this next example here. So again, same type of setup. We have an a sub n, and notice that you are given your a sub 1. If we wanted to find the first 5 terms, we already know the first one, so now we're going to go to the second one. So wherever you see an n, you're going to substitute 2. So because the equation says n times a, we're going to do 2 times a sub 2 minus 1. Again, 2 minus 1 is 1, so this is a sub 1. Well, a sub 1 is negative 3, so 2 times negative 3 is negative 6. For a sub 3, we're going to do 3 times a sub 3 minus 1. 3 minus 1 is 2, and a sub 2 is negative 6. Your second term was negative 6. So 3 times negative 6 is negative 18. And then we would do the same thing for the 4 and for the 5 to give us the 5 terms here. Another example to go through, again, notice that you're given a sub 1 to start, and all you're doing is, when you compare this original a sub n function, this equation, look at what's happening over here in the example as you're filling the numbers in. Everywhere you see an n, that's where you're making substitutions. So for a sub 2, you're putting a 2 for every n. When you see a sub 3, you're putting a 3 for every n. So at this point, you want to make sure that you're writing these out step by step and not trying to do all of this in your head. That's not going to work. You need to write out the steps because this can get a little confusing. So I'll let you take a minute to look at that. Now, those are recursive formulas, but let's talk about explicit formulas. Explicit formulas are different in that you can find a specific term directly without having to know any previous terms. So I could ask you to find the 10th term, and you could do that without knowing any of the terms before it. So for example, this says find the 15th term of the sequence defined by a sub n equals 4 and minus 1. If we want to find the 15th term, that means we want to find a sub 15. So we're still going to substitute that 15 for the n, but look at what happens when you do that. When you substitute that, you get 59. That's the 15th number in the sequence. So you don't have to know anything beforehand. On the next one, if I had said find the first 5 terms of the sequence defined by a sub n equals n squared plus 3, same thing. You're just going to substitute 1, 2, 3, 4, 5, and you get the 5 terms directly without having to know anything else. Now, I could also give you the terms of a sequence and ask you to write an explicit formula. What you have to be able to do is identify the pattern. So in the first example, it says write an explicit formula for the sequence 1, 8, 27, 64, 125. What you have to be able to do is look at these numbers and think, okay, am I adding something every time? No. Am I multiplying something every time? No. So then what kinds of numbers might these be? Do I recognize them? Might they be squares? Are they square roots? Are they cubes? And maybe this is where knowing basic facts would help. These numbers are all cubes, meaning 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, meaning the first term is 1, the second term is 8, the third term is 27. So if I wanted you to find the nth term, that means our explicit formula would be a sub n equals n cubed. Because if I then asked you, okay, what is the 6th term, you would do 6 cubed, just going in that pattern. Another example would be to write an explicit formula for this sequence 2, 3/2, 4/3, 5/4, 6/5. Now this one's a little different. If you think of the first fraction as being 2 over 1, notice that your denominators go 1, 2, 3, 4, 5, 6, and so forth. Whereas your numerators start at 2, 3, 4, 5, 6, and so on. So if you wanted an nth term formula, you would end up with n plus 1 over n, because n would be your starting number. Like if you're going to start with 1, that starts you with a 1 on the bottom. And if you did 1 plus 1 on the top, that gives you 2. So 2 over 1. The way that you check your formulas is you substitute 1, 2, 3, 4, and 5 into the formula you created and see if you get that original sequence that was given in the problem. Your homework is going to be page 603, 24 through 27, and then 33 through 35.